Hello, this video is for Chapter 2, Lesson 6 of the Algebra 1 textbook. It is titled Solving Absolute Value Equations. The objective for this lesson is to solve equations in one variable that contain absolute value expressions. Why learn this? Well, engineers can solve absolute value equations to calculate the length of a deck of a bridge, and we'll see that in example 3. So recall that the absolute value of a number is that number's distance from 0 on a number line. For example, the absolute value of -5 is +5, and the absolute value of +5 is also +5. We can see that on the number line here. We have 0 is here at this point, -5 is at this point, and +5 is at this point. So we can see from the number line that -5 is 5 units from 0, and +5 is also 5 units from 0. So for any non-zero absolute value, there are exactly two numbers with that absolute value. For example, both 5 and -5 have an absolute value of +5. To write this statement using algebra, you would write x inside of these two bars here. We read that as the absolute value of x equals 5. This equation asks what values of x have an absolute value of 5. Well, the solutions are 5 and -5. Notice that this equation has two solutions. So if you have an absolute value equation, you will have two solutions. Now later on we'll find out that it's possible to have only one solution in special cases, and then there's another special case in which there may not be a solution at all, where you would have no solution to the equation. So absolute value equations, in words we say the equation, the absolute value of x equals a. This is asking what values of x have an absolute value of a. The solutions are a and the opposite of a, or another way to say the opposite of a would be -a. In numbers, we have the absolute value of x equals 5, while the two possible solutions are x equals 5 or x equals -5. We could also represent it on a graph. We could say that we were a number of units to the left of 0 would be -a, and a number of units to the right of 0 would be a positive value of a. In algebra, we would say that the absolute value of x equals a, or x equals a, or x equals the opposite of a, or -a. And here we have to solve absolute value equations, perform inverse operations to isolate the absolute value expression on one side of the equation. Then you must consider two cases. So just like in regular equations, where if we had something like, let's work off to the side here, if I had 3x plus 4 equals 19, I would have to isolate this value of x until I got it down to where x equaled some number, correct? So we would have to get the x by itself, you might say. So whenever we work with absolute value equations, we're doing the same thing, only we're trying to get the absolute value portion of the equation isolated. And then once we do that, we're not finished. We then have to consider two possible answers, and that would be a negative version of it and a positive version of it. In our helpful hint here, be sure to check both solutions when you solve an absolute value equation, and so we'll look at that in a moment. Example 1, solving absolute value equations. Solve each equation. Our equation is x equals 4. Absolute value of x equals 4. So we rewrite our equation here. We think, what numbers are 4 units from 0? Well, it could be 4 units to the left of 0 or 4 units to the right of 0, because distance is always a positive value. You can't have a negative value for distance. I can't ask you to walk 10 negative steps in any direction. You might walk 10 steps forward or 10 steps backward, but from the point that you're at, whichever direction that you go from that point, it's always going to be a positive distance. You can't have a negative distance. So in case 1, we could set it up that we notice that we get rid of the we take care of this. The x is already isolated on the left, correct? So we have the x, again, I need to correct myself on that. The absolute value of x is isolated by itself on the left side of the equation. And then we have something on the right side of the equation. So what we need to do is remove the absolute value portion of the equation here and just write this as x, and then take the negative version of 4 and the positive version of 4. So case 1, we've removed the absolute value bars, and we just written what was on the left of the equation, which is, in this case, is just x. And on the right, we put the negative version, that is to say negative 4. But also, we could have it where the x is going to be equal to positive 4. So we pretty much already have our solutions here. You'll see that later on, it's not quite as simple all the time. So our two solutions are that x equals negative 4 and x equals positive 4. So here we have one where it gets a little more difficult. Solve each equation. And here we have B, example B. So we have the absolute value of 4 being multiplied times x plus 2. Again, this is multiplication between here, just like if we had 4x. Notice there's no operation sign between the 4 and the x. Well, likewise, if we have 4 times the absolute value of x plus 2, we have no operation symbol in between here, so we recognize that this is multiplication. It's almost like the distributive property. If we had x, 4 times the quantity of x plus 2, we would realize once again that this is multiplication in between the two of those. So we have here that 4 is being multiplied times the absolute value of x plus 2. So we need to use the opposite operation, which is division. All fractions are division, so we'll put a fraction bar here. We're going to divide by the number we wish to get rid of, which is 4. And what we do to one side, we're going to do to the other. So these 4's on the left here are going to cancel each other, leaving us with just the absolute value of x plus 2. And 24 divided by 4 equals 6. Now we have the absolute value section of the equation isolated on the left side of the equation. So our next step is consider two cases. Remove the absolute value bars and take what's inside of the absolute value bars, the x plus 2, and we're going to use that in both cases. You see it to the left in case of the equal sign in case 1, and also to the left of the equal sign in case 2. But in each case, we're going to consider the positive form of the answer and the negative form of the answer. Whenever I say the answer, I'm referring to what's on the right side of the equation. So it could be a negative 6 or it could be a positive 6. Now we have to solve both these equations to find both of the solutions to this particular absolute value equation. So on case 1, we're adding 2, so let's subtract 2. And what we do to one side, we do to the other. These 2's will cancel each other, leaving us with just x, and negative 6 minus negative 2. Actually, negative 6 minus 2 is negative 8. So we have x equals negative 8. That's one of our solutions. Now we still have the other solution where it could equal positive 6. So we're going to subtract 2 to undo the adding 2. That gets rid of the 2's here, and we just get x. Then 6 minus 2 is 4. So our second solution is 4. So the two solutions for this equation, 4 times the absolute value of x plus 2 equals 24, are negative 8 and positive 4. Let's look at a couple examples here. We'll do the first one over here. So I have x minus the absolute value of x minus 3 equals 4. I need to get rid of the negative 3 because I want to isolate the absolute value of x, everything inside the absolute value sign. So I'm going to add 3. What I do to one side, I do to the other. The 3 is going to cancel each other. I'm going to end up with just the absolute value of x equals, in this case, 7. Now I'm going to take away the absolute value brackets and just consider x, and then the negative version of it, negative 7, and also the positive version of it, positive 7. So my two solutions are negative 7 and positive 7. So this table here summarizes the steps for solving absolute value equations. To solve an absolute value equation, the first step is to use inverse operations to isolate the absolute value expression. This is where we want to get the absolute value portion of the equation all by itself on one side of the equation. The second step is to rewrite the resulting equation as two cases that do not involve absolute values. So in the second step, we're going to create two equations. We're going to take what's inside of the absolute value bracket, and we're going to put it on one side of the equation. And then whatever is on the right side of the equation, we're going to use the negative form of that. And then again, we're going to do the same with the second one and use the positive form of that, which is step 3, solve the equation in each of the two cases. Not all absolute value equations have two solutions. I referenced this whenever we started off on the first slide, that sometimes there could be no solution and other times there could be one solution. If the absolute value expression equals 0, there is one solution. If an equation states that an absolute value is negative, then there are no solutions. The reason for this is if your absolute value expression equals 0, well, 0 is right at 0. Zero is, there's no number. I guess what I'm saying is that if your equation is going to equal 0, then there's no distance to two different numbers. Both of your equations would land right at 0, and then they would be equal. Therefore, there would only be one answer. The portion where it says that if an equation states that an absolute value is negative, that there's no solution, that's because it is impossible to have the absolute value of x equal some negative value. We'll just say negative a. This here is, you cannot do. There's not a solution. There's no number, no value of x that we could find that would produce for us a negative distance, because remember, absolute value is all about distance. Distance can't be negative. So if you come up with something that where you get the absolute value portion of the equation isolated on one side of the equation, and the other side of the equation now has a negative number, at that point you can just stop there, because you know that, well, there is no solution to a situation like that. So let's look at the first special case where we're going to get, looks like we're going to get just one solution. So we have absolute value of x plus 3 plus 4 equals 4. So we have the positive 4 that is being added to the absolute value of x plus 3. So let's get rid of the positive 4 with the negative 4. What we do to one side, we're going to do to the other. Then 4 is going to cancel each other, leaving us with just the absolute value of x plus 3 on the left. And 4 minus 4 is 0. We now have that the absolute value of x plus 3 equals 0. So at this point right here, we would know there's only going to be one solution. And to find that one solution, we'll go ahead and remove the brackets here, and we'll just put x plus 3 and set it equal to 0. Because since 0 has no, there's not like a positive 0 and a negative 0 we could use. 0 is just 0. So we'll only have one equation that we'll have to work with, or one case that you might say. Remember, case 1, that's negative. Case 2, where it's positive. In this case, we only have one case because we don't have a positive or a negative number. All we have is 0. So we have plus 3. Let's go ahead and subtract 3. What we do to one side, we do to the other. The 3's will cancel each other, leaving us with just x, and 0 minus 3 is negative 3. Therefore, the only solution to this equation here is x equals negative 3. Let's look at the special case that we see here in example B. So we have 5 equals the absolute value of x plus 2 plus 8. So we have the 8 that's being added to the absolute value of x plus 2. So let's go ahead and get rid of the positive 8 with a negative 8. And what we do to one side, we're going to do to the other. So we're going to go ahead and subtract 8 from the left side as well. The positive 8, negative 8 cancels each other, and we end up with just the absolute value of x plus 2 on the right. And 5 minus 8 equals negative 3. Well, this is where we have a problem, because there's no way that you can get the absolute value of something and have it equal a negative number. So therefore, the equation has no solution. So let's go ahead and look at, let's try solve 2a. We'll go ahead and work on 2a. So looking at this one here, I have 2 minus the absolute value of 2x minus 5. And this is supposed to equal 7. So I need to get rid of the 2. I need to isolate the 2x minus 5, correct? I got to get it all by itself isolated first before I can do anything. So let's go ahead and subtract 2 from each side, all right? Because I want to get rid of this positive 2 here. So those 2's will cancel each other, leaving me with negative absolute value 2x minus 5. And 7 minus 2 is 5. Now I still have this negative sign out here in front of the absolute value of 2x minus 5. Well, I'm going to go ahead and change my ink color here. And remember that there's like a 1 right here. This would be kind of picture negative 1 being there. So if that were the case, we realize, oh, okay, well, I need to divide by negative 1. And what I do to one side, I do to the other. Then that means these negative 1's will cancel each other. And I'll end up with 2x minus 5, the absolute value of 2x minus 5, equals, and then 5 divided by negative 1 is negative 5. Now I have a situation where I have the absolute value on the left isolated, and it is supposed to equal a negative number. Well, we can see, like in example B here, that there's no solution for that. There's no way I'm going to be able to do anything with what's inside of this absolute value brackets that is going to produce a negative 5, because absolute values are always positive. So since I've isolated the absolute value portion of the equation, and on the right-hand side, or the other side of the equation, either way you want to look at it, that I have a negative number, so that means that there is no possible solution. So here's example 3 about the engineer application. So we have Sydney Harbour Bridge in Australia is 1,149 meters long. Because of changes in temperature, the bridge can expand or contract by as much as 420 millimeters. Write and solve an absolute value equation to find the minimum and maximum lengths of the bridge. Well, notice that the bridge is in meters, but the amount that it can contract or expand is in millimeters. So our first step is to convert millimeters to meters. So 422 millimeters, we would move the decimal point 3 places to the left, and we would end up with 0.42 meters is equal to 420 millimeters. So the length of the bridge can vary by 0.42 meters. So find two numbers that are 0.42 units away from 1,149 on a number line. And we can see that here. And I've also replicated that on this next slide here. This here portion is a repeat from the previous slide at the bottom here. So here is our number line representing the distance of 0.42 less than 1,149 and 0.42 units greater than 1,149. You can find these numbers by using the absolute value equation of x minus 1,149 equals 0.42. And if you think about it, we're having the minus side. It's kind of like, I can picture it in my mind. I'm really having a hard time kind of expressing it in words. But if it can vary by 0.42, and this is the length of the bridge, means the bridge can get that much shorter. That is to be, if it were to contract, the bridge would get shorter by that much. And if it were to expand, then it would be getting longer by that much. And we'll be able to find the distance to each side, to the right and left of it, using the concept of absolute value. And we'll go ahead and use subtraction. So solve the equation by rewriting it as two cases. Well, we already have the absolute value portion of the equation isolated on the left, and nothing being added to it. It's not being multiplied by anything or divided by anything. So we can go ahead and set up our case 1 and case 2. Remember, we want a case in which the answer is negative. We can see here negative 0.42, and case 2 where the answer is positive. We have a positive 0.42. Solving for each of those, we're going to add 1,149 to the left, and what we do to the left, we're going to do to the right, and we end up with x equals 1,148.55. On the right-hand side, where our case 2, where our answer is positive, we add 1,149 to both sides, and we get x equals 1,149.42. So the minimum length of the bridge is 1,148.58 meters, and the maximum length of the bridge is 1,149.2 meters. So in our guided practice here, let's look at a couple of them. Number 1's pretty easy, right? We know that the absolute value of x equals 6. Well, that's going to have to be either a negative 6 or a positive 6. Over here, number 2, we have the 9 equals absolute value of x plus 5. Well, if I rewrite that as x plus 5 equals 9, we see that we already have the absolute value portion isolated on one side of it. So let's make our two cases. X plus 5 equals negative 9. And the other case could be x plus 5 equals a positive 9. So we subtract 5 from each side. On this side, we're going to get x equals, and negative 9 minus negative 5, or we're actually adding a negative 5, is going to be negative 14. And if we subtract 5 here from each side, we're going to get x equals positive 4. So negative 14 and positive 4 are the two answers for that one. Let's look and see what else might we want to do. Let's try number 6 right here. We have the absolute value of x minus 3 minus 6 equals 2. So let's go ahead and add 6 to each side to get rid of that. So that's going to leave me with the absolute value of x minus 3 and equals, because those 6's canceled each other, and 2 plus 6 is going to be 8. So I now have the absolute value isolated on one side. So I'm going to write two cases of x minus 3 equals a negative 8, or x minus 3 can equal a positive 8. Go ahead and add 3 to each side. And here I get x equals, and negative 8 plus 3 is going to be what, negative 5. And over here, if I add 3, I'm going to get x equals 11. So in this case, for number 6, it was negative 5 and positive 11. What about number 8? Absolute value of x equals 0. There's just one possible answer here, right? Just 0. This is one where we get just the case of 0. I'm looking for, let's try number 9. These should be like special cases. Let's see which special case. So everything in example 2, questions 7 through 12 should either be one solution or no solution. So let's see what number 9 is. Absolute value of x plus 4 is already isolated on the left. And, oh, I'm done, right? It equals a negative number. So there's no solution here, right? No solution, because it equals a negative number. Let's see. On this one here, if we were to subtract 7, on number 10 here, if we were to subtract 7 from each side, we would get, those would cancel, and we'd end up with 0 over here on the left. So we have the absolute value of something equals 0. So we know that there's just going to be one solution for this. So we would take the 3x plus 9, and it can only equal 0. And we'll go ahead and subtract 9 from each side. And then we'll go ahead and divide by 3 on each of them, and we would get x equals negative 3. All right, that's pretty much all I think I'm going to do for this activity. So that concludes the instruction for Chapter 2, Lesson 6 of the Algebra 1 textbook, Solving Absolute Value Equations. Thank you.